I hope everyone's doing well. I'm Tommy Wen Chin of San Jose State. I did my summer research through Cowbridge, funded by the NSF, and it was a privilege working with Dr. Mu-Chun Chen of UC Irvine on a theoretical neutrino physics project. Today, we're going to ponder about why do we exist? If you take a look at the objects around you, chances are they're made of matter. I'm made of matter, and you are too. In other words, we're made of protons, neutrons, and electrons. Electrons are part of a larger family of leptons. Like anything, matter has its equal and opposite counterpart, antimatter. Take the electron, for example. When matter and antimatter come in contact, they'll destroy each other. At the beginning of time, equal proportions of matter and antimatter were created. Now, 14 billion years later, you'd expect that everything would eventually destroy each other, leaving us with an empty universe. However, I still exist, and you're still here too. Somehow we're left with more matter than antimatter. Somehow there's this matter-antimatter asymmetry. And our question is, what happened? What mechanism could lead to such an asymmetry? Physicists believe that neutrinos might hold the answer. They consist of three flavors: the electron neutrino, the muon neutrino, and the tau neutrino. And they alternate between their flavors as they travel through space. We call this neutrino oscillations. Building off theoretical models by Denton, Park, and Zhang, we plot on the x-axis the distance a group of neutrinos that are traveling through vacuum. On the y-axis, we plot the fraction that are electron, muon, and tau neutrinos. We started off with 100% mu and 0 the others. And depending on where we make our measurements, we'll get different fractions. For example, 80% mu, 20% tau, or 85% tau, 10% mu, and 5% e. If we continue allowing our neutrinos to travel, they'll continue oscillating. What we'll start to notice is the electron neutrinos, the green, starts to shift upwards, whereas the other two are coming down. And that's because the total always have to add up to 100%. Now you'll see the electron neutrinos come down again. And so they don't only oscillate at the small scale, but also at the large scale. Neutrinos can be created at particle accelerators. This one in particular is at Fermilab. We would then send them off to South Dakota for measurements. How far away we make our measurements depends on the fraction that we're interested in. Almost all measurements are done underground, isolated from our noise. Because of that, it is crucial we model neutrinos traveling through matter as opposed to vacuum. And that is exactly what we did this summer. Among the three leptons, electrons are the majority in matter. And so as our neutrinos travel through matter, only the electron neutrinos are affected. The mu and the tau neutrinos zip past through. And so in our model, we incorporate a parameter A that measures the electron density. In other words, the number of electrons. And what we observe is that the electron neutrinos, the green, starts to go down, down, and down, and down. They're all being deflected. Now, this is what we're here for. In our model, we have a parameter delta that measures the charge parity violation. Charge violation is when physics treats matter and antimatter differently. Parity violation is when physics treats our objects and their mirror image differently. Charge parity violation is when we switch our mirror image to antimatter, and if physics treats the two differently, then there is a violation. This difference in physics treatment is crucial in addressing the matter-antimatter asymmetry. And so in our model, as we increase the charge parity violation, what we notice is the green and the blue, the E and the tau neutrinos, start to shift to the left. And so when the experiment produces their results, we can then compare them to the plots generated by our model and see which one matches the best, telling us the value of delta and the amount of charge parity violation. When that happens, we might not only address the matter-antimatter asymmetry, we might even answer our bigger question of why do we exist? Thank you.